So we need to be able to write an exponential or logarithmic equation given a set of points. In this case, we're looking at an exponential equation from a set of points. We're not going to be doing anything tricky on these. These are just going to be in y equals a times b to the x form. So we're not looking at translating these left, right, up, down. We're just looking at a vertical shrink or stretch of some kind of an exponential function. So if this is my general form, and inside each ordered pair I have an x and a y, I can write two different equations that fit this form. So 36 is y equals a, which I don't know, times b, which I don't know, to the second power. Likewise, 3, which is y, equals a times b to the first power. Because I can write these two different equations, I can now actually divide both sides. So 36 divided by 3 is 12. AB squared divided by AB to the first is just b to the first, because the a's would cancel, and b squared divided by b to the first is just b. So now I know in my final equation that the b is 12, but I don't know what the a is. I'm going to go back to one of my equations. Y equals the a I'm looking for times b, which is 12, to the x is 1 in this case, to the first power. Oh, so 3 equals 12a, which means a has to equal 3 divided by 12, which is 0.25. My final equation, y equals 0.25, which is my a, times b, which is 12, to the x power. So, going with my y equals a times b to the x, and I always do what's going to be the largest exponent in my first equation. So I'm not getting down here and finding a negative exponent on my b. So, y is 18 equals a, which I don't know, times b, which I don't know, to the x power. The second one, y equals a times b to the x power. Then I'm going to divide, so 18 divided by 2 is 9. Again, the a divided by a would cancel out, and b to the fourth divided by b squared is b squared. To solve 9 equals b squared, I would have to square root both sides, so b equals 3. And we're only going to be dealing with the positive root for these. So I know b equals 3. I don't know what a is, so I'm going to take the easiest point, which is for me 2. Y equals a, which I'm looking for, times b to the x power. So 2 equals 3 squared is 9a. Dividing by sides by 2, a equals 2/9. Now it does say round answers to 3 decimal places were needed. I don't need to round this. It's a rational number. So do not give me 0.222. Give me 2/9. So y equals a, which is 2/9, times b, which is 3, to the x power. Same thing, only this one's not going to work out as nicely. So y is 10 equals a times b to the x, which is 2 power. Y is 0.5 equals a times b to the x, which is negative 1 power. I'm going to divide those two equations. 10 divided by 0.5 is 20. Again, my a's would cancel, and b squared divided by b to the negative 1 is b cubed. Oh, so I'm going to have to cube root both sides. So b is the cube root of 20, which ends up to 3 decimal places being 2.714. Normally I don't round in the middle, but some of these problems are going to get so complex later that we are just going to use the rounded b here. So I'm going to use this point because it looks easier. Y equals the a I'm looking for, that vertical shrink or stretch, times b, which is 2.714, to the x power. Now I'm not going to square this and get another rounded number. I'm going to say to find a, I would have to take 10 and divide it by 2.714 squared. plug that into your calculator all at once. So 10 divided by 2.714 squared equals, to 3 decimal places, 1.358. So y equals a, which is 1.358, times b, which is 2.714, to the x power. Now, likewise on the graphs, you're going to get some, I can tell immediately, this is a logarithmic function again, and an exponential function. We are not going to be doing shrinks or stretches on these. These are simply going to be translated. So all I do when I look at this one is I notice that, again, remember that this is a logarithmic function, and I notice that it's this kind of anchor spot is where it normally is, because anything to the 0 power is 1. So this one's actually not translated left, right, up, or down at all. So then I look up to where 1 is, and ooh, the 0.51 is on this graph. So something to the first power equals 5. Oh, so my base has to be a base 5, because 5 to the first power equals 5. So y equals the base 5 log of x. Here, I notice that this is actually translated 1, 2, 3, 4 to the right. If it's translated 4 to the right, I know this is going to be an x minus 4. The log base something of x minus 4. Well, the something is, I go up and I say, oh, here's one higher than that, and if I translate back 1, 2, 3, 4, it'd be saying some number to the first power equals 3, so this has to be a base 3 logarithm. Again, we're not on these graphs going to get into any shrinks or stretches or anything else fancy. Normally, on a regular exponential function, my y-intercept is at 1, because anything to the 0 power is 1. So this actually has translated up 4, which means this is going to be a plus 4 at the end, because it's translated up 4. Y equals something to the x plus 4. Well, if it's translated 4, then I look where it's gone here. It goes 1, 2, 3, 4. Oh, normally there would have been a point here. Something to the first power equals 2, which means my base has to be 2. Y equals 2 to the x plus 4.